This video will show you how to draw a force diagram. Okay, today we're going to learn how to draw a force diagram. If you look, forces are any pushes or pulls that are acting on an object. There are 4 forces that we're going to talk about. We always represent our object by drawing a box. If you're pushing an object or pulling an object, we represent that with an arrow in the direction of the push or the pull. Pushes and pulls can go in either direction. If an object's sitting on a flat surface, such as a table or the ground, the force of gravity is pushing down on the object. Because the object's not falling through the table or the ground has to be pushing back up on the object with the same force, and we call this upward force the normal force. You can see this if you're using a weak table or a weak chair. If the normal force is not strong enough to counteract the gravity force, then the object falls through it and falls to the ground. Normally, your normal and your gravity are the same as long as an object's sitting on a flat surface. So these are our main forces that you're going to see. Pushes or pulls, gravity, and the normal force. Now there's a couple exceptions that come into place depending on if something's moving horizontally or vertically. If an object is on a surface and moving horizontally, we still show it with a box. We will have gravity pushing down. We'll have the normal force pushing up. Then if we're pushing or pulling the object in this direction, since there are 2 surfaces touching right here, we are going to have a friction force trying to stop our object from moving. Friction is what you get when 2 surfaces rub against each other. If an object's free falling, if it's falling through the ground, notice there's no surface. Gravity will still be acting on the object, pulling it down. But since there's nothing supporting it, there's no normal force. Instead, we have air resistance acting to try and stop the object from falling. And you'll notice, if the gravity is greater than the air resistance, the object falls. If the gravity is less than the air resistance, the object will start to slow down. Now we can actually put numbers to these. Let's look at these 2 examples. 2 students push on a box to the right with 10 newtons of force each. So here's my box. I have 2 students pushing to the right. Here's my first student. He's pushing with a force of 10. Here's my second student. He's pushing with a force of 10. The friction force on the box is 8 newtons. Friction works in the opposite direction, so here's my 8. The box has a weight of 25 newtons, so gravity is pushing down with 25 newtons. And it's sitting on the floor, which tells me that the normal force is also 25 newtons. So if we look at the horizontal and the vertical components. Horizontal, we have 25 pushing up. Vertical, we have 25 pushing up, 25 pushing down. We have the net force of 0. That's why our box is sitting flat. Our horizontal forces, we have 10 plus 10 to the right, which is 20, minus 8 to the left, which means we have 12 newtons of force, and it's going to be in the direction of the right. Let's try this last one. In a tug of war, 2 teams are pulling on a rope in opposite directions. So here's my middle. Team 1 is pulling with a force of 40 newtons. Team 2 is pulling with a force of 35 newtons. What direction will the rope be moving, and with what magnitude? 40 newtons minus the 35. We're going to have a net force of 5 newtons, and my rope will be moving to the right. On the back of this worksheet, if it says just diagram the forces, just draw me a picture. If you're given calculate the forces like we did on the other side.